All right, we'll just go through this problem set. So the first one says draw a tangent line where x is equal to 1. So where x is equal to 1 are functions here. So the tangent line should be something like that, that just nearly touches it, gets close, but doesn't actually cross over it. X 2.5 would be over here. So if I have to imagine the slope, I'd assume it would be something like that, would be the tangent line. And then finally 0.5. So I find 0.5 along the bottom where our function is, and our tangent line might look something like so. So the red one would be the most steep. The tangent line where x is 1 would be the next most steep, I guess the middle steepness, and then the one at 2.5 would be the least steep. So continue along here. For the following, draw a tangent line to the graph as the point indicated. So same idea, like so, at 3. At 30, it's very similar to the ones that were in the notes for this. And at 5. So one thing that we got to pay attention to is the first 3 were positive because they're going up from left to right, and the fourth one is decreasing because it's falling from left to right. Keep going. Draw a tangent line to these graphs so we kind of get the idea after a while. At 0.5 and then at 2.5. So the idea is that the slope is changing everywhere. So that's tangent lines. It says of the 2 points listed above, where is the graph decreasing the fastest? So I would say at x is equal to 0.5 is decreasing because it's most steep, fastest. So this spot here is decreasing at a faster rate than this spot here. So it's only asking us to compare those two. So that first one's decreasing faster because it's more of a steep line. It's dropping faster. Number 4, what is the average rate of change in population for the first 4 weeks? So we're saying from week 1 to week 4. I want to know what is the average rate of change over that. So the first point is at 0 and 50. The second point that we're dealing with is at 4 and, let me erase that, it's kind of 4 and looks to be about maybe 140. Put it back on. I just wanted to see if it was above or below that line of 150. So I just used the slope formula. Slope formula said subtract my y's. 140 take away 50, all over 4 take away 0. When I subtract those ones, I get 90 divided by 4, and I get 22.5. So the average rate of change between the first week and the fourth week is 22.5 based on that. Next it says, what is the instantaneous rate of change at week 4? So I'm going to erase this from our graph. Instantaneous rate of change just means spot here. I'm interested in what is the slope of a line that would kind of look something like that. So depending on the person, your line might be a little bit more steep or less steep than your friends. But I choose 2 points that are on this line. So maybe I choose this point here for me, 2 and 50. And another point that's on that tangent line, I don't know, maybe way over here. I'll call that 7 and 250. You might not choose the exact same points as me, but you should get a slope that's relatively close, maybe a little bit more steep or a little bit less. But remember, we're just using our eye, so we can't really know exactly. So we'd have 250 minus 50. I'm subtracting my y's. All over difference in my x's, 7 take away 2. So I subtract them, I get 200 all over 5. So 200 divided by 5 is 40. So that's the instantaneous rate of change at 4 weeks. You probably have something pretty close to that. Within 5 of either side is fine. Just because we're using our eye in our own tangent line that we drew from, as I said, using our eye. Next one, 5. The graph at the right shows the distance traveled by a person over an 8-week period. Find the average rate of change for a person for the entire 8-second interval. So we're going from 0 and 2 all the way up here, which is at 8 and 6. So essentially what we're doing is finding out the slope of a line that goes directly from one to the other. That'll be the average rate of change. I know in this section here, they're going slower. I know over here, they're going faster because it's more steep, but we want the average rate of change. So once again, I subtract my y's, 6 take away 2, subtract my x's, 8 take away 0. It doesn't matter which order I put them. I happen to choose the point on the right to put into my formula first. And I got 4 over 8, which is a half. Just want to show you that it doesn't matter if I happen to use the point on the left first. Subtract my y's, 2 take away 6, and subtract my x values, 0 take away 8. Using that point on the left first, I would get negative 4 over negative 8, which is also 1 over 2. So both work out to be the same. The average rate of change is half in that case. Without doing any calculations, do you expect the instantaneous rate of change at 6 to be faster or slower than the average rate of change? So what I can do is think of where 6 is. 6 is about right here. And if I drew my tangent line to that, something like this, I'd say it kind of almost looks the same. Maybe a little bit more steep. But based on your tangent line you draw, I'd say it's pretty close to the same. About the same, because those two lines look pretty parallel to me. But let's do our calculations and see. So that one, you're just making a judgment call, what you think based on the line that you drew. But if I want to find my average rate of change, well, I'm going to choose 2 points that are on my tangent line. So maybe if I extend it over here, maybe I'll choose the point at 0, 0. And I'll use the point of our tangent line, maybe 6 and 3. And I'll find the slope between 0, 0 and 6 and 3. So our y values, 3 take away 0, divided by 6 take away 0, which is 3 divided by 6, which is a half. So it tends to be the same rate of change at 6 compared to the average rate of change over the first 8 weeks. Now, once again, your line might be a little bit more steep or a little bit less steep. You might have a different slope, but that's the idea behind what we're working on. Next, it says, was the rate of change positive or negative? How does that connect to the graph? Well, the rate of change is positive because we got positive a half. How does that connect to the graph? The slope is increasing from left to right. From left to right. So that's that one. Keep rolling along here. Water is leaking from a tank. The amount of water left in the tank measured by thousands of liters after X hours is shown on the graph. How much water was in the tank originally? So we're just wondering at time 0 right here, how much water was in the tank? Well, it looks to me to be 8, or in this case, 8,000 liters. Because it says it's in thousands. Next, what was the average rate of change in water from 0 hours to 2 hours? So I find where 2 hours is right here. And really what I'm trying to do is find the slope of a direct line. That's the average rate of change between those two. So I look for my coordinates. Well, first one is at 0 and 8. That's a start. Next one was at 2 and 1. About. And I find my slope of that average rate of change. So subtract my y's, 1 take away 8. Subtract my x's, 2 take away 0. I'm going to get negative 7 over 2, which is negative 3.5. So what does that mean? It means that for every hour that passes, we're losing 3,500 liters of water in the tank, is what that's saying. So now it says approximate the instantaneous rate of change at 2 hours. So when we find that instantaneous rate of change by not actually doing our calculations, but using a tangent line, maybe tangent line looks something like that. I find some points along the graph, or that line, I guess. Maybe something here looks to be at about, let me redo that one. Oops. What am I doing? I'll redo that tangent line. Maybe something that looks like that with a dot here and a dot here. Sorry about that. And if I wanted the points, I would say this one is at 0.5 and looks to me to be about 2.5. And the one that we have down here looks to be at about 3 and 0. So I'm going to find my slope between those 2 points. I'm going to subtract my y's. So 0 take away 2.5. All over, subtract my x's. 3 take away 0.5, which is negative 2.5 over 2.5, which is negative 1, which means we're losing 1,000 liters of water in the tank every hour that passes, or right at that spot is the average rate of change. So was the average rate of change positive or negative, and how does it connect to the graph? So in this case, it's negative. It's negative 1. And the red line is falling from left to right. The tangent is falling from left to right. And that's how we calculate those. Keep going here. Go back to blue. It says the graph on the right shows the height of a ball thrown in the air over time. What is the time period that the instant rate of change, where the instantaneous rate of change in the graph is negative? Well, that would be where it's falling. So I would say everywhere after this top spot. So I would say all of the time between 5 and where it ends at about 9.8 is where the graph is negative. So we could say when x is greater than 5. So the right side of the graph is basically what that's saying, because it's negative because it's falling from left to right. During what period of time is the instantaneous rate of change positive? So when is the height going up? Well, that's the first half of the graph. I would say everywhere between 0 and 5. All that section in there. Basically the left side of the graph, the red part. So what is the instantaneous rate of change at 5 seconds? Well, what does this mean here? Well, if I was to draw a tangent at 5 seconds, it'd be a flat line like this. Anywhere the graph changes from increasing to decreasing, or from decreasing to increasing, like a vertex, slope is always going to be 0. So there is no rate of change. It's not increasing, it's not decreasing. It's at the top, suspended there for a second, and then it's going to start coming back down. What else is special about the 5 seconds in relation to quadratics? Well, that was called the vertex. Or still is called the vertex. It's the maximum, where the highest point of the ball reaches. And that's that for the first one. If any questions, let me know, and we'll talk soon.